Hello YouTube. Today at powerjackrepair.org we got the board that says MS-17f41. On the board I will see what MSI or Asus or whatever the laptop it's from. Now the problem I already pretty much found what the problem is. The laptop came in for the power jack repair, but I could see that there is nothing wrong with the power connector. So I took the voltmeter and saw if there is a shortage on the board, and you want to check the shortage right behind the two diodes. So this is a ground and this should be a plus, and it shows me 0 ohm resistance, meaning if you're watching it on big screen in 4K you should be able to see that it shows 0 ohms like that, and I'm putting it right here. All right, instead it should be showing something like that, you see? Should be showing some resistance, but instead it shows us 0 ohms, meaning when the laptop is being powered up, the power supply is being shut down because it encounters a short right there, and those guys don't conduct the electricity further through. They shut down something right here. Now, the reason I'm showing you this video because I already found what the problem is, and let me show you how I found it. First of all, we add the wire right here. We solder the wire. We connect the positive end of the non-interruptible power supply. Non-interruptible, meaning that in case it encounters a short, it doesn't shut down itself. Ground, we just connect to the ground. And this is how the power supply looks like that. We set it for 19 volts and 2 amps. I know it should be like 5 amps or something, but we start low. And then once we press the button to supply the power, it's going to supply the power to the motherboard. Then we have I'm not going to advertise this company because I don't really like this infrared camera. It's supposed to show me where the heat spot is at. Right now it doesn't show any heat spot anywhere, but I will switch you to the output from this camera and we will see where the spot is at. So let's switch to the infrared, and then let's power up the power and see if it's gonna find the spot. So we're switching to the infrared. Okay, so this is the board. We look to the left, we look to the right, and no heat spots anywhere. This is a ground wire right here. All right, so this is a ground wire. This is a plus wire, which we're gonna slightly put aside. And let's power up the power supply. All right, so the power supply has been powered up, and somebody has nothing to do other than call me. And we ask everyone to text us. All right, so we got the positive wire on the hot. You see, this is where it's connecting to the motherboard. And now if we go lower the motherboard, we have a ground wire, and we got that's a USB cable it turned out. And here we got the heat spot right here. You see? Right there. Right there. All right. So we're switching back to the view, and we got a heat spot right here. All right, so we shut it down. We shut down the infrared camera. And now we're gonna look under the microscope and see what's going on right there. All right. So we disconnect the power supply. We want to shut down the power supply. We already know where the shortage is at, and that's how you find the shortages here. Let's see if you're gonna be able to. First of all, I need to get rid of this wire now, desolder it from the motherboard, and then we need to look at at what's going on here. So let's switch to the other camera and the other workstation. All right, so the first thing we need to do is we need to desolder the wire from the motherboard. All right, and let's remove excess solder from it. Alrighty. Excess solder has been removed. Well, the thing is, I usually don't desolder the wire until the end of the repair, but here I'm pretty much sure I know what the problem is. So now what we want to do is we want to fire up the microscope and see if we're gonna be able to show you what the problem is. All right, the microscope, I got like $1,000-something microscope, which takes time to power up. This is not like an analog microscope. Let's switch to the, let's rotate the whole thing. Oh, I just messed up something on the microscope and too much. Okay, so let's switch to the microscope. All right, and that's where the heat spot was at. So if you look closer, the microscope shows us clearly that we got, let's see, this guy right here, which is melted. You see? I mean, this one looks fine, this one doesn't look fine. This looks fine, this looks fine. So let's remove this. This is a capacitor. Let's remove this capacitor and see if it's gonna solve our problem. And let's see if I could utilize the tweezers for a cleaner, capacitor removal. First, what I wanna do is I wanna add some solder to the capacitor. I mean, I'm probably gonna end up removing it using the hot air, but I wanna try the tweezers first because those capacitors are not that big. So maybe the heat from the tweezers, from the hot tweezers, gonna be enough. Unfortunately for me, $1,000 spent on those micro tweezers never paid off, simply because I don't use them that much often and they don't do a good job because it's a micro tweezers. It's not, there are much bigger tweezers out there. You see, it doesn't even pick up this item without the heat because the board is so thermally, no, it doesn't want to go. Yeah, what a waste of my money and a waste of my time. Yeah, I guess those are gonna be okay for those type of capacitors, but for this big capacitor, this is not working out. I knew, no, I mean, I got every single tool in the race to have. This is how the work looks like that. All right, but you see, it doesn't wanna, not enough thermal conductivity to move this guy. So let's do an old trick. See if the thermal conductivity of the two soldering irons gonna be able to move this guy off. Nope. Yeah, I mean, I need to remove it by hot air. I was hoping the hot tweezers gonna help me out here, but they don't. All right. You see, the capacitor is even cracked on the inside. It's not me who cracked the capacitor, it's the capacitor that was cracked to begin with. All right. All right, so don't waste your money on those, even though it's made in Japan, should be like super duper micro tweezers, but it's a waste of everybody's time. All right, let's shut down the micro tweezers. Let's clean up the area. So yeah, so that's how you basically find the shortage, and I hope that everything should be working fine after that. Well, it's not exactly necessary to remove this guy, but I just don't want anything being stuck there. Come on, seriously. I guess when it cracks, it melts the board in. Well, I guess I just have to leave it like that. Let's clean up this guy. Let's clean up that guy. Come on. Get off the motherboard. Those are the remains of that capacitor. Please, 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 come on. Dude. Seriously. This isn't... I was hoping it's gonna be much easier said than done in this case. Alright, come on. Yeah, I mean, this board just sucks all the heat inwards. It doesn't let anything. Good job, MSI. I mean, how could you just sit there? It should be surface mounted. How can you suck all the heat in? It's just small little piece. Alright. Yeah, guys, basically, if you got this board, use the hot air station, because this is not working out for anybody here. Alright. You know what? You suck. Alright. Well, okay, you win. Let's use the hot air. This is just not going anywhere. Hopefully we're not gonna blow any components of the motherboard, and we're not gonna melt anything around here. Hopefully. That's the keyword. Come on. You see how easy it is with the hot air. Good job. Yeah, what a useless tweezers. Useless tweezers. Alrighty. Let's clean this guy up. Let's clean up all the area around here. Alright. Good job, good job. Alrighty. Oh, everything moved. Here we got E. Here, let's see if this capacitor is the same. I don't want to unpack it if it's not the right size. Let's see. Yeah, looks the same. Okay, let's open it up. Looks similar. Yeah. All right, let's try and solder this guy up. And you know what? Let's first add some flux. I don't know what now would be a good time to use those tweezers. I already shut everything down. Let's see if we can just use the big iron to solder things up here. Maybe I need a smaller iron for this job. Let's get this guy placed right here. I should have grabbed it with the wrong. It's not working out for me. Okay. All right. Come on, rotate a little bit to the top. All right, good job. Good job, a bit more. Nah. Come on. Think it grabs onto from the both sides. Let's see if we can. Come on, come on, come on, come on, come on, come on. Yeah, no, I probably need to use hot air on this guy too. Good job? Oh, no, it's a good job. Looks good. Let's see if the side got soldered. Nope, it's sitting up in the air, so that's a bad soldering job right there. All right. So let's bring the hot air. You see why it's important to have a $3D $1,000 microscope. Come on. Oh, come on, you should be already in place. Yep. Oh no, you're being blown off. All right, let's do something different. Here, let's shut down this guy. Let's add a little bit more solder on this side. All right, good job. Now let's rotate the again, hot air. I need to bring hot air again. All right, let's do hot air again. I know what, let's switch the hands. Much better with the tweezers in the other hand. Come on, come on, come on. As much as I didn't want to use the hot air for this kind of replacement, I ended up using it. And now it blows away. All right, good job. All right, good job. Let's see. Beautiful. Beautiful. All right, let's clean everything up. So all the investments are not necessary if you got a good hot air. You know what? I think this capacitor is not the right size. You see this capacitor is slightly bigger than this guy. Yeah. I was thinking it's exactly the same thing, but it's not. Well, let's see if it's gonna work on the load. All right. Well, the worst case, I could just remove that capacitor and be done with it. Oh. Yeah. I mean, this is the most common capacitor I replace. I didn't expect it would be slightly taller. Maybe just this guy sits slightly higher on the board. Oh, you know what? It's the same capacitor. But you see what they did here? They did some sort of metal here and a metal here, and between those two metals sits a capacitor. No, I mean the capacitor is exactly the same. That's what I had difficulty with. It had a metal bracket like that soldered to the motherboard, and inside of that metal bracket was a capacitor shoved in. Like here, you see? Metal bracket, and a capacitor, and it's... Oh wow, it even sits off the board. Wow, I didn't expect anything like that. That's honestly the first time I see something like that. Wow, take a look. You can shove something underneath it. Wow. Well, you see, overcomplications is what causing the capacitors to overheat and die. And I just want to get all the flux out from underneath it. And I guess I need to clean it up a bit more. Alrighty. Yeah, I was wondering why my capacitor is slightly smaller in size. Turned out to be it's not smaller, just not that bracket that I had a hard time removing. That's the... Alright, let's bring the lint-free pads. Alright, let's see. Alrighty, so I'm just gonna test to make sure that the board is not shorting anymore. And we're gonna be sending it back to the client. I'm sure everything's gonna be working fine, because it was pretty obvious problem. I mean, it was right there on the surface. All right, good job. Alrighty, so we are back at the main take part station, again, powerjackrepair.org. Let's take a look if we still get a shortage. First of all, I want to make sure that we got no shortage here. And we shouldn't. Hold on 1 second here. Like that, everything's connected. Okay, we got no shortage. All right, and here we're gonna measure the shortage, if there's a shortage between the negative and the positive. And we got no shortage, you see? It doesn't go all the way to 0, like that. It's here. All right, so the only thing left to do is connect the power supply to the jack and see if we get the... Where is the battery terminal? Oh, right here. If we get everything going to the battery, everything should be fine, but I'm sure it's gonna be fine. Thanks so much for watching. Please leave a like, subscribe, and you guys take care and have a good day. Donations are appreciated if you have exactly the same model. Thank you. Bye.